All right, good morning, everyone. So the session for today is the flavors of non-clustered indexes. I apologize for the lack of the "of" in the title and when it was posted online. For some reason, I must not have reread that out loud, and it kind of probably felt a little awkward saying the name of the title. The topic of today is, of course, non-clustered indexes, a topic that I've talked about here a few other times. Some of this might sound a little bit familiar if you've seen the other non-clustered index sessions that I've done. But the main point that I'm getting at here today is people need to pay attention to the ways in which non-clustered indexes can be put together and take advantage of it. Just the building of non-clustered indexes when I go out to clients is something that is a fairly easy thing to use to solve problems and performance issues at clients. And so I like to go in and talk about them over and over again to drive home that message.
Jason, could I get
so
you...
as already stated, my name is Jason Straight. Sure.
Hey, I'm sorry to interrupt. Could I get you to turn off your Skype? Or you just had a pop-up?
That was my phone. That was making that sound.
Okay.
I just silenced it, got it out of the way there.
Okay, but it showed some messages, so does that show up on your screen?
No, nothing showed up on my screen because I've got Skype, email, and link turned off.
Okay. All right.
I'm not sure what would have popped up.
Okay.
Oh, you know what? I know what it was. One moment. There we go. It was Twitter.
Awesome. Thank you.
All right. Sorry about that. Thought I'd gotten all of them. So, my name is Jason Straight. If you have questions about indexing afterwards, please put them into or even throughout the session, please put them into the Q&A box. I will answer them as best we can. If you want to get to this presentation and other resources that I've put together on indexing, you can go to jasonstraight.com/go/indexing. All the materials presented today will be available later on. And I've done quite a bit with indexing over the years. I actually have a book that I put out with A-Press on performance indexing. So if you want to learn more afterwards, there is plenty of resources out there. I am with Pragmatic Works. Pragmatic Works hosts these Tuesday and Thursday training sessions. Basically, if it is being done with SQL Server, Pragmatic Works can probably put it together for you. But getting started here today, before I get into the agenda, I just want to point out that we talked about a little bit of ice cream facts before we started today, and you will see lots and lots of pictures of ice cream in the session today. Hopefully that doesn't make anyone hungry and force them to go out and get some ice cream today. So when it comes to non-clustered indexes, there's lots of ways that these can be put together. There's a lot of options that are available with non-clustered indexes, and there's things that you need to think about whenever you're making any non-clustered index to make sure that everything gets put together the way it is, because any query that you run on your system, there is a set of indexes that can be built and put together for it that is going to make things just work good together. And so, you want to get the ones that are built out there that are perfect for you, that bring out that happiness, that make everything just jive together. And that's kind of what we're going to be talking today. And you want to be careful when you're building all of these that you don't, get that brain freeze from your ice cream and slow things down by overbuilding and over allocating out your resources. A lot of what we're going to talk today is about building non-clustered indexes. I'll do a presentation in the future where we can talk about how to destroy the indexes that you've built, or more put in a better way, to get rid of the ones that you don't need and do some index maintenance. But today we're going to just talk about building out those indexes, and so that at the end you can take all of this information that we're going to go through today, and you can use it to evaluate what indexes you want to build and figure out exactly how to cobble it all together. Hopefully get something that looks about as nice as this banana split on the screen looks. So we're talking about non-clustered indexes, and non-clustered indexes is basically a way to build a secondary path into any of your tables. We build clustered indexes so that we can go directly to the rows that we hit the most often. And so those are the indexes that are associated with the ID columns that are on our tables. But there are other ways that we need to get to the data. If you've got a search where you're searching for last name, you don't want to scan the entire table. You want to be able to go directly to people with, say, last name of street, because it's not going to be the entire table. In my experience, there's not a lot of streets out there, and so if you're going to be doing a search just for my last name, you want to be able to go directly to those rows. You don't need to look at 2 billion rows to find the one or two rows out there. They are sorted. They're sorted from left to right within non-clustered indexes. You can have one or more columns. Every single non-clustered index has pointers back to either the heap or the clustered index rows that are associated with it. And then the other thing is, on these key columns, you can never have LOB data. All the large object data that's out there cannot be in your non-clustered indexes as key columns. The operations that SQL Server will do if you give it some non-clustered indexes to work with is it's going to do index seeks and index scans. And by having these index seeks and index scans off on secondary indexes, these non-clustered indexes, you can avoid having scans on your clustered indexes, because anything that SQL Server is going to use to go through on your non-clustered index is typically something that would not have resulted in a seek on your clustered index. And that's that value that you get out of the non-clustered index, is that ability to go in and get everything pulled together. So there's 6 things that we're going to talk about today when it comes to the flavors of non-clustered indexes. I've kind of pulled through the ice cream theme here, and so we're going to talk about just vanilla non-clustered indexes. We're going to talk about building up a sundae with your non-clustered indexes. We're going to talk a little bit of Neapolitan non-clustered indexes, then a little bit of Rocky Road. We're going to talk about some sugar cones, and then we're going to talk about gelato. So when we're talking about vanilla here today, what we're really talking about, what I really mean when I say we're talking about the vanilla indexes, is we're just talking about a non-clustered index that only has one column in it. This is going to be the most common type of index that you're going to be looking at building. Now, in the end, it may not be the most common index that's out on all of your tables, but it's going to be that starting place. If you have nothing else, at least have some single column indexes on your tables that highlight these other values that you go in and access data through. So with a single column, the data is sorted by the key columns. That column that you use for the non-clustered index, that's how everything is being sorted. It does also include the clustered index keys or the heap row identifiers. And you typically focus this on the columns most frequently used for your filters. So it could be a social security number, it could be a last name or first name. If there's order IDs, not order IDs, but order numbers, if there's account numbers, these things that are non-primary key columns that you also search on, these are the ones that you're going to be going to with your single column indexes. Now, you don't want to index every single column on your table. It may seem like, hey, that's a good idea, but no, you don't ever want to do this. I've worked on a few systems where people have gone this route, where just having all of these indexes on the tables seemed like a good idea. A lot of them started with DTA underscore, which implies that the database engine tuning advisor was used to build a lot of these. And there was a database I worked with that on average per table there were over, I believe, 50 indexes per table. When we just pulled off all of the indexes that weren't being used whatsoever, we saw a significant performance improvement just in that, just on read access, because we took away the compile time for a lot of these queries. So you definitely don't want to index everything, but you do want to make sure that you index the things that you're most often filtering on. Now, for all of these, I do want to show you guys some demos and examples on how this all works and the value that it provides within your application. So to get this going, I'm going to use this context table. In this context table, I've got a few of the columns that come in from the person.person and person.email address tables from the AdventureWorks database. All of these demos are based upon the AdventureWorks database, so everything will be there. And it'll be easy for people to pull together. So let me just get this created here real quick. And once we've got that created, let's turn on actual execution plans. And I just want to start off by showing, if I search and go through the entire table, pull back every single record, it's going to result in 2,866 logical reads. So that's the entire table. And if I wanted to filter for just one person, so I just want to pull Catherine out of this whole mix, there are only 22 rows that have Catherine in them. So one would expect that with 22 rows out of a possible 19,000 rows, that you'd see a much smaller amount of pages accessed, not that 2,866. But when you don't have any indexes besides the clustered index that was first created for this table, you're going to get still that 2,866 reads. Now this table is fairly small in comparison to what SQL Server can push through. In this small little database, doing a scan on the table every single time is not going to cause that much problem. And you can see here, it took 0 seconds to complete this. We don't want to really pay attention to that when we're talking about these 19,000 records, because you want to think about your systems where you're doing joins between multiple tables and the effect of that's going to have on performance, and the fact that a lot of our tables have 1 million, 2 million, 1 billion records in them. When you're talking about large data and you think about these 2,866 pages, think about larger tables and the impacts that this would all have on it. Now I'm just going to do a single column index like we were talking about on first name. So if I get that created, and I'm choosing first name because first name is what we've been doing a filter on here, I'm just going to run a query against this index, against the table again, run that same query. Don't try to recreate the non-clustered index. Now that I've created that index, instead of 2,866 reads, there's 2 reads. On these 2 pages, these 22 rows exist, and you can get all of the data that way. And if we look at the execution plan here, SQL Server is able to do a seek on that non-clustered index that was created, that just simple vanilla index, to reduce the amount of pages that are being accessed, to improve the performance of the query, and things are running pretty much a lot better. And that's a really simple thing that a lot of people miss when I'm going and doing performance assessments, is these tiny little one-column indexes provide a significant performance improvement, that you get this stuff laid out there and things are just going to start working so much better. Now, of course, sometimes you may have multiple single column indexes, and in this case, these are our sundaes. We're going to pull together and we're going to build a banana split, we're going to bring our chocolate, we're going to bring our vanilla, and we're going to throw it together into one dish. And that can happen within SQL Server, and it's one of those things that you can't necessarily try and force this behavior to occur, but it's one of those things that will happen with SQL Server, and that's called index intersection. And if you have multiple non-clustered indexes that can service a single query, SQL Server can actually find intersect positions between those and bring you just the results where those 2 pieces overlap. And so when you filter 2 indexes that you have built out, SQL Server can intersect the 2 of those together. And this is one of those interesting behaviors that a lot of people don't pay too much attention to, but it's one of those things that that SQL Server will use, and you can build indexes up around to help this behavior. Now, what we're looking at in this case, though, is we've already built a query that goes through and for first name Catherine optimizes those results. So quick. And so if we add in a last name search, and this is last name with the existing indexes that we have built out there, what we're going to see is that in the execution plan, it's going to continue to do the index seek on the first name index, but it doesn't have any way to get to the last name data, so it's going to do key lookups to pull back all of the last name information and pull that in there and do the filtering for that last name. And instead of the 2 reads that we got originally, now we're getting 68 reads. Not a huge number, 68, but if you think about that 2 to 68, this is 30 times less performant than the previous. But what you can do is create an additional single column index on last name, get that index built out, and we can run, and instead of the 68 reads, we go back down to 5 reads. And so what SQL Server is doing here to get only these 5 reads is just like I showed in the slide. If I get the zoom in, we're getting all of the records from the index seek on first name. It's going back and doing an index seek on last name. And then that area in the middle here, where we have the overlap, is being merged into each other, and those results are streaming back through to you. And so index intersection gives you the ability to leverage multiple single column indexes as you get them built out and pull those results together. And that's one of the reasons why you got to make sure that you have not just one column out there. So if you do most of your searches on first name and only sometimes do things on last name, you're still going to want to build out last name indexes so that you have this ability to do this index intersection. Now, of course, index intersection doesn't give you the best performance when you start optimizing your non-clustered indexes. You're going to want to do a little bit more with your non-clustered indexes, and sometimes you don't just want a sundae. Sometimes you don't want to sit and take the time to build your sundae and put things together. Sometimes maybe you just want ice cream that has all of those flavors in it, so it has all of the columns that you want to get to. Maybe you want the chocolate and the vanilla, and you want it all together, and you want it every day together like that. And so you can get a Neapolitan type of an index put together so you can pull everything together. And I'm starting to actually myself want some ice cream right now. And when we're talking about a Neapolitan type of index, what we're talking about is a multi-column index. The way to pull 2 or more columns together into the same index, they are sorted from left to right. You can't skip over columns to leverage the sort, but you can optimize for the sort here. This index is then able to cover the entire index, and sometimes you hear people talk about covering indexes, and multi-column indexes can help you when you're doing 2 things. One, you have 2 columns that you want to do a sort on, do a sort and filtering on, and so you can use the multi-column index for getting into both of those, and so you can sort by last name, and then you can sort by first name, and then you can sort by last name. And so when you look for a first name and a last name together, it can find the 1 or 2 rows that exactly match to that. The second thing is if you have columns that don't quite fit into your index, on the filtering, you can add those also, but they're in the query. You can put them into the multi-column index as well, and they'll be sorted, but you'll be able to cover all of the columns required for your query. Now, the value in doing multi-column indexes is that it reduces the number of indexes that you're going to end up needing. And the reason why it reduces the number of indexes is if you go and put single column indexes on 4, 5, 6 different columns, and you're looking for the index intersection so you can get the 2 filters to come together and give you the results that come out, that's going to start building up lots and lots of indexes. And you want to avoid having lots of indexes on the table as much as possible, and so by doing multi-column indexes, you can consolidate down the number of indexes that you need a little bit. So let's look at some Neapolitan indexes or multi-column indexes, however you want to put it. So we're going to build out. We've been doing our searches on our query on first name, last name, and as we saw before, if we do Catherine and Cox, and we run through that, there we go, we get those 5 reads. But let's build out a non-clustered index on this context table for first name and last name. And that's the 2 columns that we're accessing here. And so we can build that index, get that created. And now we've got an index that covers both of those. And so instead of doing a seek across 2 separate indexes, can now do a seek across just one index and then go directly to those results. Now from a performance perspective, if you recall, on the index intersection it was 5 reads. When you have it down to one single index that can filter on both of those columns, it drops the reads down to 2 reads. And so you're back to that place where you were for performance when you're talking about a single column index. But from a reads perspective, you're doing 2 filters with the same 2 reads. The next thing I talked about was covering indexes. Now, if you recall, I said that when you build out non-clustered indexes, the clustering key goes into the non-clustered index. And so when I'm running these queries, I'm getting contact ID from the non-clustered indexes. I'm getting first name from from the first column in the index, and I'm getting last name from the second column in the index. What happens if you throw in an additional column here into the index? So you're adding in an additional column that isn't part of the non-clustered indexes, and you're having it here and continuing to do that filter. And this is that idea of the covering index. So sometimes you have additional columns that you bring in, but they're not there, so SQL Server has to do a key lookup. Anytime SQL Server needs to get just a little bit more, they need just one more column, one more piece of data, SQL Server will do a key lookup to pull that out of the clustered index or the heap that's associated with that non-clustered index. And if you look at what's happening in the key lookup, the only thing it's doing is going through and pulling in the isActive column. And it's doing that by doing a key lookup based upon contact ID. Well, with a covering index, even though you're not using it as a filter, you can throw that into the index as an additional key column. And when you throw it in as an additional key column, if we go through and we run that again, we can drop back down to 2 reads. And just as an FYI, I did point this out in the last one, but prior to adding in the covering index, it was back up to 5 reads. And then we can look at the execution plan, and in the execution plan, it's now using the first name, last name is active index, and it's able to do a seek again and go directly to that data. So there are 2 things that you can use multi-column indexes for. One is to expand on a search so that you can look for multiple columns within your search and be able to search through all of those. And the second is to be able to add in additional columns to avoid that key lookup, because that key lookup does drive up the I/O and it increases the amount of work that SQL Server has to do in order to service your queries. Now, one thing that I have been asked before, and I'll build out an index for this really quick, is, let me see here. Let me see, where is that? Let me just drop this index real quick. Does the order of the columns in the non-clustered indexes matter? And I just want to show you that it does. Let me pull back. This is the index I want to drop. Let me drop this one. So we don't have a last name index. And so if we do a search on first name, last name, and we only want to search on last name, and we don't have a last name index because I just deleted the last name index, and if I show you all the indexes on this table, and we'll just look at just this one table, just to show you the indexes so that you guys know what's there. So if we take a look at it, we've got an index on first name, an index on first name and last name, and then a non-clustered index, a clustered index on contact ID. So there is no index on first name, on last name. And so if we do a search on a query on contact ID, first name, last name, if we go on Cox and just searching by the last name, let me run through that real quick. So I'll run that. And if we take a look at the reads, and in this case we got 99 reads. And the thing that I'm pointing out here right now is when you're doing a search and you're using a non-clustered index and you're not searching on the leftmost column, will it still use that index, and will it still use it well? And so pay attention to the 99 reads. This is 99 compared to 2 when we were doing this and had the last name index. It will use the last name, the first name, last name index, but because the leftmost column, which is first name, isn't being used in the filter, and only the last name is being used, SQL Server can leverage that, and it can pull that out, but it's not using it as a sort. It's using the first name, last name index because it's a smaller index compared to the clustered index, but it's not able to go through and use the sort of the last names within there, because before you can get to Catherine Cox, so if you've got Catherine and you've got all the Catherines together, and then somewhere in there there's a Cox, and then you might have a John somewhere in here, and so you have a bunch of Johns, and somewhere in there is a Cox. SQL Server doesn't have a secondary sort that goes through these last names. It only has a sort that starts from the left side that goes through each first name and then the last names. So each first name and then the last names. And that's something I like to point out to people, because SQL Server looks like it's leveraging the index. I've had a few people in the past say, oh no, it can use the index and it'll be sorted. No, it'll use the index, but it won't sort on those leftmost columns unless that leftmost column is being used as one of the filters within there. So just to get things back to where they were before, let's rebuild these, because I'll need these in further demos. Make sure this one's there. Yep, that one's there. So that's the multi-column indexes. And of course, as we're going through this, please add in any questions into the slide panel, and I will get to all the questions here at the end. Now, the fourth flavor or way to throw together indexes is the rocky road. Sometimes you've got the right flavor, and so you're picking out the right flavor, but you need a little bit more. Maybe you need some nuts and berries. Maybe you need some marshmallows thrown in. You've got some extra stuff that you want as a part of your ice cream, and that's when you turn to things like Rocky Road. And when it comes to non-clustered indexes, sometimes you have the columns that you're filtering on, and those filters are all the flavors that we're talking about, but you've got that extra column, that extra bit, that marshmallow, or that is active column that's not part of the index that you want to have there, and you want it to be available so that you can just bring it back. You don't need to do any sorts or filtering on it. Well, that's what is available when you use included columns. Included columns bring in those nuts, those berries, those marshmallows that aren't part of the core flavor of the ice cream, but they give it what you need in order to have the ice cream that you want. So you can build up the index to have additional columns that you need to just return, but without having to worry about the sort. And the reason why you want to do this is if you've got 5 or 6 columns that you just want to bring back, you don't need them sorted, you can add them into your non-clustered index, and then they're only stored once within the non-clustered index. They're only stored at the leaf level of the index. Whenever you add in additional columns and you're using the multi-column covering index process for having these additional columns in, those values actually get stored at every level of the index. And if you do a very wide index in those kind of cases, you can make very large indexes where values are out there and at all of the leaf levels, and that can actually affect performance. And so if you bring those columns that you don't need for anything other than select statements and you drop them into included columns, you can include the data with the index and bring it all back together. The one thing to point out is that within included columns, these are all unsorted. I did not want to zoom there. There we go. These are all unsorted. And so there is no sort with these within any of the indexes. Also, don't include all columns as included columns within your indexes, or even most of the columns. You want to be selective when you're building out included columns and make sure you only have the ones you absolutely need. And the reason why you want to watch this is the update rate. If you're updating columns and they're in the included columns within the data pages, you're going to have to update those every single time that you update those columns in every single place. And so you need to be cautious of that. When it comes to included columns, let me show you how they help and benefit. And included columns are something that they've been around for a while, but I don't see a lot of people taking advantage of them and using them appropriately. And what I mean by appropriately is that I often see column indexes that have no clustered indexes, no included columns, and those are the majority of the indexes in the database, or even sometimes all of the database, all of the indexes in the database. And then other times I'll see some indexes with included columns, but there's 15, 20, 30 columns that are included. I don't have any really good situations where I've thought of where you'd want 15, 20, or 30 columns in your included columns. When you're talking about included columns, generally what I'm feeling like I'm hitting the fringe of it is when I've got 5 or 6 columns there. And so you want to pay attention to that. So let's go back to our example. We're going to talk about Catherine Cox some more, and we're going to bring in email address. Now, if you recall, email address hasn't been a part of any of the indexes that are out there, and so if we query on that, we go to the right database, we're going to get an execution plan that does that key lookup again. And we've been seeing this over and over again, and if we take a look at it, we can see that, why did it turn blank? Let me try one more time. We can see that the email address is the reason why it's going to the key lookup, so it can pull that in. So we take a look at the reads, and the reads as compared to before is up to 68. Prior to having the email address on there, it was 2 reads. And so we want to improve the performance of this. And what we can do to do that is we'll add in, since we're only filtering on first name, we can add in a last name and is active and an email address column into a first name key column index. And we'll call it first name included. And if we run through that and pull just the Catherines out, so we're going to get all 22 Catherines. Oh, let's actually create the index. There we go. So we get that index created. If we take a look at the execution plan, now instead of an index seek with a key lookup, we get just the index seek. And so because everything that the query needs, the first name, the last name, the email address, the contact ID, if we were able to see that, we've got all of that up here. And so we can build that index, build the query results without going to anywhere else, because that's all been included. And so if we take now a look at the table, we're going to see that there are a lot of indexes. And there's a couple ways that we can get to this. I'm going to just show you using sysindexes, but then I'm also going to use this index analysis script. SP index analysis is a script that I have available on my blog site. This pulls together a lot of index metadata. So if we run through that, we can see that we've got all the contacts. We've got the 2-column index on first name, last name. We've got a first name index. We've got a first name with included columns indexes. We've got a last name index. We've got first name, last name is active. And we've got this thing here that I'm not sure why this showed up, but we'll just ignore that for today. So and if we just scroll over just a little bit here, whoops. There's the included columns that I talked about. And so that's all the indexes. And if we take a look at the indexes that are out here, though, there's a pretty common theme. We've got first name, last name. We've got first name. We got first name. We got first name. So we have 4 indexes that start off pretty much exactly the same. And then we've got a last name index, which we probably need since none of these other ones start with first name for our last name only searches. So we've got these 3. We've got this one. They're pretty much all the same. There's a little bit of variation in it. We've got last name is active. We've got last name. We got last name is active here, and then we also have email address. One of the things that we can do is, what if we were to delete some of these? So we've got these 4. And so what if we get rid of this one, we get rid of this one, and we get rid of this one? When you have included columns, there's some interesting things that can happen when you start looking at some of the other indexes that are out there. Especially if you know that every single time that you do a first name search, well, every time you do a last name search, you're always going to do a first name search. If you're going to look for email address, well, you're always going to also look for first name. And so if you know some of that stuff about the systems that you're working with, you can get rid of some of your indexes. And let me show you real quick. We've got all of those indexes. Let me just run through and leverage all of these and show you the performance that comes out, because we've got indexes built for each one of these to make them run better. And so if we run all 3 of these, we're going to see that we get an index seek for all 3. The performance that we got back for all 3 was 2 reads, well, 3 reads, 2 reads, and 2 reads. So that's the optimal reads that we can get for these. But let's drop out all of them except for the non-clustered indexes index with the included columns. And so if we go back and we take a look at the indexes for the table now, instead of having 6 indexes on the table, we've now got 2. 1 for first name, 1 for last name, and then some included columns on the first name index. If we run all 3 of these now, we're going to get a little bit different performance. But one thing to point out first is we get index seeks for all of these. None of them have key lookups. And what's going on is SQL Server is able to go through and find everything it needs within the index without having to go to other indexes. And what's happening here with this first name, last name search, even though there isn't, so there's the first name grouping for Catherine, and then there's data pages for the columns. What SQL Server is able to do is go and find Catherine and then go within here and find and scan across the last names to find the last name that matches for Catherine Cox. And so you can consolidate some of your indexes by leveraging included columns for your secondary column searches. And what you're going to see is that it doesn't have that much of an effect on performance. We're still getting 3 reads on the first one, and we're getting 3 reads on the second 2, so 1 more read for those by getting rid of the perfect index and using one that is good enough for that query. So included columns give you that ability to change up the flavors and change up how everything works within your indexes, and you can get more mileage out of your indexes because now that we only have 2 indexes on the table, 2 non-clustered indexes on the table, we can look at the other columns that are on the table and maybe index some of those a little bit differently so that we can optimize the indexes for this table. And that's the reason why you're going to want to throw together some rocky road on your databases so that you can get your indexes laid out and perfected as much as possible. So the next thing we want to talk about is sometimes you don't want a giant dish of ice cream. Sometimes maybe you just want to throw a couple scoops onto a sugar cone, and that's what I want to talk about next. And my sugar cones for our non-clustered indexes and getting that flavor thrown together is really filtered indexes. Filtered indexes is something a lot of people really need to start taking and paying a lot more attention to. What filtered indexes do is give you the ability to add a where clause onto your index to remove everything else, everything but what fits within that where clause from your index. And so you can take an index that is gigs in size and drop it down to a few megs in size. And when you're talking about something that drops down to a few megs in size, you're reducing the number of pages, you're reducing the size of that index, and if you're only using, say, the data from the last 30 days, well, if your filter index only has the data from the last 30 days, then when you have to defragment, when you have to maintain it, when you need to make changes to it, all of that's going to happen much more quickly because you can go in there. And if you have a billion row table and you've got 1,000 row filter index, the thought of doing a scan against 1,000 index with 1,000 rows is not as scary as the thought of accidentally kicking off a scan based on your queries on a billion row table. And that's what filtered index gives you. The one thing that you need to watch whenever you're using filtered indexes is there is an unmatched index warning that's out there, which basically tells you, hey, you're using filtered indexes incorrectly. Why don't you go back and take a look at this query and maybe you can use a filtered index for it. And so I'm going to show you both filtered indexes and the unmatched index warning so that you can pull that information out. Because there is a few things that are kind of catches when it comes to using filtered indexes. So let's start off. We're going to take a look at the context table again. We're going to look at the rows where certification date is not null. And so we've got a table that's got 19,000 records, but only 10 of them, only 10, have values. And of those 10, within this range for 2005, there are only two rows. So out of 19,000 records, 2 rows fit with what we're looking at. So let me go and take a look, turn on actual execution plans. I'm going to run these both together because I want to show you what happens when we run these, because there's nothing indexing these yet. And so we can start with taking a look at the execution plans, and as you might guess, both of these execution plans are going to do scans against the entire table. There's no index to support any of this. So let's start, and we'll take a look at 2,866. Let's start by taking a look at building an index on certification date. We'll put in first name and last name because that's what we're bringing back. So we've got first name and last name covered through an included columns, and we've got certification dates, so we can pull out these values. And we're going to skip that for the moment because I want to show you before we run this. So we got that. If we run the queries again and take a look at it, we can solve this with an index that covers everything. But What if this table was 1 billion records? And so out of the 19,000, only 10. And out of our query, only 2. Well, if we're talking about a table with 1 billion records and we're only accessing a very small portion of it, why should we build an index that has 19,000 minus 10 records where there's no values in them whatsoever? Wouldn't it be better to instead create an index where, since we only care about the ones where certification is not null, let's just create an index that covers that. And so the entire index is covered within just this one little area. And if we take a look at, and let me actually create 2 copies of this index. We'll build one without the, there we go. If we take a look at the index, just grab, instead of rewriting this yet again, if we take a look at the index, try this one more time, there we go. If we take a look at it, there we go. Now we can take a look at it. We've got the 2 indexes. We've got certification date 1 and 2. If we take a look at the size of these 2, there is the size. Adding in the filter, we get an index that's 0.2 megabytes. So we're talking about a fairly smaller index, 20 kilobytes. Add in all of the rows and we get 1 megabyte. And so the index with the filter on it is much smaller. And so the search space for it is quite a bit smaller. And the memory footprint for this index, for the one with the filter on it, is much smaller. So if I push the entire index up into memory, it's going to be much smaller. And if we run the queries that go with it, these queries are going to come back and bring back require a small number of reads, only 2 reads per. And if I take a look at what indexes are being used, for some reason it's using certification date 2, so let's just drop certification date 2. It shouldn't have used that. Here we go, run them again, just to show that it's going to use them both. So 2 reads, take a look at the execution plan. It is using the certification date index, which has the filter on it. But there's a catch when it comes to filtered indexes. You may then say that you want to find all of the certification dates where let's just copy this out. There you go. So I'm going to do just pull back just one of these. If we take a look at what's going on here, we're going to see 2 reads again. It's continuing to use the certification date. So there we go. One of the problems that can occur when you're talking about using filtered indexes is there may come a point in the future where you want to take this certification date and wrap this whole thing into a store procedure. And when it comes to wrapping this into a store procedure, you're going to find out that there is a catch when it comes to filtered indexes, that if it can't know for sure what a filter is going to be, what a value for it is going to be, that SQL Server is going to actually do something that you didn't expect. And actually, in this case, this time I didn't expect it to do that. I did expect it not to use this. Not really sure why it's not doing that. Can't put is null there. All right, I'm not really sure why it's doing this, so let me just I didn't double check this one piece last night. I just assumed that this would work similar to the other ones that I've done in the past. The problem that you can run into with filtered indexes, and let me just bring up a different script and a different way to get about this to the exact same problem that I'm working on here. Okay, going to look at this just a little bit different here, where I'm looking at production product ID. Apologies for not double checking the second piece, but when you're talking about filtered indexes, of course, like I've said, you want to limit the values that you're going to be looking for. And so we're going to shift gears a little bit here, and instead of looking at a sugar cone, we're looking at a waffle cone now. And in this waffle cone, we're going to be pulling back production products. And let me just make sure I'm on the right database here, get this created. If we take a look at this product that we're going to pull back, this water bottle or this waffle cone, we're going to build a query that goes out and pulls that information back. If we take a look at the query, 1,246 reads. So if we know that every single time that we ever go to pull this information back, that we're going to go through and always be looking at product ID. All right, good. I just wanted to make sure that that index wasn't there. We're going to see that we may not get the most optimal execution plan, because in this case we had 1,246 reads. Well, those 1,246 reads actually think that they can be better if they had a better index in place. And I talked about included columns where we don't want to throw tons and tons of columns in. Well, what if you get an index recommendation that's telling you, hey, you actually need a whole bunch of columns in order to satisfy this query for one single index. And in this case, it wants sales order ID, sales order detail ID, carrier number, order number, discount, line total, modified date, to be able to service this query. Well, we probably don't want to build that index, but we kind of need that index. And so a way to get around that is actually through filtered indexes. Like I mentioned, filtered indexes are a smaller subset of the table. And what if you knew for a fact that every single time that you ran this query, it was going to be between product IDs 800 and 900? Well, instead of covering the entire index, entire table with this filtered index, you could just cover 800 to 900. And when you run that now, instead of the 1,246 reads, you're going to get just 37 reads. Now, picking up where I was leaving off last time, if you want to genericize this and turn product ID into this product ID search into a store procedure, you would declare a product ID, pass it in, and then you end up with the perfect little query that you want to use. So you're going to go through here and you're going to see that it's now doing an index scan on the clustered index, and that's exactly not what you want. And in fact, if you go and look at the reads, instead of having the 37 reads, it's now up to 1,246 reads. Well, that's what we want to avoid. And with filtered indexes, in order to avoid that, you actually have to include the filtered columns in the filter in order to get the reads that you want. And so that gets us back down to 50 reads compared to the 1,246. There is a way to get around this, and that's by using Dynamic SQL, and so I can run that with Dynamic SQL, and we get back down to the 2 reads. Actually, this should be 870. This actually gets back down to the 37 reads. There we go. And it's continuing to use that index seek. Now, just to step back just a little bit here, there is ways that you can find out when you're inappropriately using filtered indexes, and that's the unmatched indexes flag that shows up in execution plans, and so you can go out there and you can pull those back out. So I lost a little bit of track there because my demo didn't break the way that I wanted it to. It broke in a completely different way by being successful. But the last thing I want to talk about here is gelato. And the reason why I talk about gelato isn't necessarily ice cream. It's a variation of ice cream, and it's not exactly what you see all the time, and that's where I want to finish off here today. And that's by talking about foreign key indexes. When you're building out the flavors for your indexes, sometimes you just got to build out stuff that fits for everything. So those foreign values that are within your tables, you need to keep them indexed. And I talk about this one a lot because this is an easy one that's going to be a silent killer of your database sitting in the background. And by indexing foreign keys, you're going to actually reduce some locking and blocking and deadlocks, because when a foreign key needs to go out and validate its values, if it doesn't have an index on it, it's going to end up producing an index scan. Now we're out of time for today, but I do have the script that's out here. And let me just run through it here real quick. And actually, I can run through this real quick. It shouldn't take too much time. Let me just script this. If we pull back the most recent one, we don't have this index, and we're just going to delete it. When you don't have your foreign keys indexed, what you're going to end up seeing is that when it goes to validate the index, it's going to result in index scans to validate those values from the other tables. In this case, we're just trying to delete out one table, but it's got to do an index scan on two tables because that secondary value, that customer ID, hasn't been validated. And so, I mean, it doesn't have an index on it to improve the performance. And if you just add an index onto that foreign key column, and we do that, delete again, and the max value right now should be 700. Yep, so 700, and we delete that out. If we take a look at that delete, instead of a scan, you're getting a seek. And that's where indexing on your clustered indexes can help. And I didn't highlight this too much, but it's really the difference between, there we go. It's really the difference between 4,513 reads and 2 reads. And this is a silent killer that I see happen on a lot of databases. Now, just to summarize here today, before we get to some of the questions, which I'm not sure I'm going to have time to get to the questions, but I will answer all the questions in a blog post that I'm going to follow up with by tomorrow. You can get vanilla information on indexes. It's all out there. You can vary the flavors and get things thrown together properly. Take advantage of the pieces that you have out there, because if you pull this all together, you're going to get a much better performance out of your databases. And make sure that you're filtering your indexes. You're having those included columns, and you're bringing in multiple columns so that you get everything running along the lines that you're looking for. And so just to, as one last plug, there is a performance tuning bootcamp coming up through Pragmatic Works. It's coming up here in March in LA. If you want to go to LA for a week and hear about performance tuning, there is about 3/4 of a day where I just talk strictly about indexes, and I go for about 5 hours. So if you want to hear a whole bunch more about indexes, there is that. There's also more training on the T stuff that I've done over the last few months or last year.